Today in lecture, we revisited a really old topic, probably back in November, maybe October, when we first did arrays. First of all, arrays are objects, so you can make them with the new keyword. You can say int bracket bracket z equals new int and give it a size. Okay, so since we can use a new keyword to instantiate them, it should be obvious that they are indeed objects. Sometimes we create arrays like this. The array named x equals 4, 5, and 6. And then if we say this array named y equals x, well, now y has all the contents of x. Now if I set y of 0 to 999, it's pretty obvious, I think, to all my kids, all my students, that now y of 0 is 999, and then the other positions are 5 and 6. Okay? But what's not so obvious, or at least what we forget, is that since we're not using the new keyword here to instantiate y is the same thing as x. I think in the video, the author said, some people call me Dad and some people call me Charles, but I'm the same person. And so you can call this array x, or you can call this array y, but it's still the same array. So as we change y, we're going to change x. Or if we changed x, we'd be changing y. And we can prove that here. And you see that x was changed also because it's the same array as y. Now, that mattered on our last quiz. I didn't take off for it because we hadn't talked about it in a while, and it's a very tough topic, but it's getting close to the AP exam. I'll have to quiz you on that one day soon. Consider this word list class. A word list is an array of strings. The constructor gets a string array and sets the instance field equal to the parameter string list. Okay? Then consider a replace method. Okay? Replace is going to replace the string at position POF with string S. Okay? Very simple method, but we can get into trouble here with it. Look what I've done. Just like in that previous thing, what did I do? I made one array y equal to another. So those two arrays are the same array. So here I am making the string array temp equal to my list, but my list is also equal to temp. You got it? So when I change temp, I'm also changing my list. And it's common for the AP exam to tell us that a postcondition of this method, that means what happens after the method executes, is that the object does not change. That's the instance field of this object, this.mylist, must remain unchanged. And we're going to change it. Okay, we can prove that with a word list tester. I've got a string array named words. Apple, banana, and cherry are in words. I make a word list object with that string array. So now W has a my list equal to apple, banana, and cherry. I'll display W and see apple, banana, and cherry. Then I'll call the replace method, which should return a new word list with the same values as word list W, except for banana is replaced with Batman. And when I display W again, I see that I have indeed changed my list of W. Okay, it's definitely a deep concept, but if you're thinking about passing the AP exam, especially getting a 4 or 5, you need to understand this. So let's just make sure you believe me first when I run it. Okay, so W was apple, banana, and cherry. We made a new word list, and that word list was based on the string array named temp. It became apple, banana, and cherry. I mean, apple, Batman, cherry. And so did the original word list W. That was not our intention to change W. We don't want to change W. So there's a few things you can do. Probably the first thing that comes into mind is say string temp equals new int and give it size mylist.length. And then I guess we'd have to loop through. You don't know what size it is. You go I less than mylist.length or I less than temp.length. They're the same length. And let's see, we'd have to put the values into temp. And then after the loop is over, say temp of position POS equals S. And then make that out of there. And now hopefully we'll not see Batman inside W, the word list W. I'm missing a parenthesis here. Boy, what am I doing? Goes new int, new string, not int. Boy, I'm making mistakes, aren't I? String, not int. All right, now we're good with that. And the tester. And so now we see that W maintains its integrity. It remains unchanged as the post condition told us it had to. Okay.